In this video, we are going to go over ratios and proportions. You can ignore this percent of change bit right here. We'll go over this next time in the next PowerPoint. But this one is solely on ratios and proportions. Now, ratios and proportions are things you're going to be using all throughout your math career. So it's really important we get this down and that you understand the relationship between ratios and proportions. All right, a ratio is when you want to compare two numbers. Okay, any two numbers, you compare them in a ratio using division, and that's what makes this important. Now, there are three different ways to write ratios. You can either write it as x to y, or with a semicolon, or with a division bar. But honestly, you read all of these the exact same way, x to y. All of these can be read that exact same way. The reason why we use ratios is a lot like putting a fraction over a common denominator in order to add them. Okay? The reason why we put fractions, if we're trying to add 2 over 5 plus 1, we would need to put 1 over a common denominator. We need to get it on the same level as the fraction in order to compare them. Because as it is right now, you can't add these two. They're not on the same level. Same thing with ratios. In order to compare a lot of different things, you need a common reference. It's the exact same logic as the common denominator. In order to compare, say, one side of a shape to another side of a shape, or in order to compare a map to the actual physical distance in a city, this common reference helps you transfer and go back and forth. Now, proportions are when you're comparing two different ratios. Now, in this one, you're trying to figure out if two different ratios are equivalent or are the same ratio. So, again, a ratio is just a number over another number. So each of these two things, these numbers right here, are ratios. You have 2 over 3 and you have 16 over 24. What we want to know with proportions is, are these two ratios the same ratio? Are these two ratios the same number? So think of this like if you're trying to build a model airplane. Okay, and one set of instructions says, for every inch on your model airplane, you're going to have a foot on the actual airplane. And another one over here says, for every centimeter on your model airplane, you're going to have a meter on the actual airplane. The question we're trying to ask is, are these two airplanes going to be the same size? If they are, then the proportions will be equal. Now, the first way you figure this out is to see if these two simplify into the same fraction. So I have 2 over 3. And that can't be simplified any further. And I want to know, is it similar, or is it equivalent to 16 over 24? Well, now I can reduce 16 over 24. I can actually reduce that by 4. So 2 over 3, 4 over 6, and that can go further. 2 over 3 is equal to 2 over 3. Yes, it is. These two things are proportionate. And what makes a proportion is this equal sign. Without an equal sign, you're just looking at two ratios. You just have a list of fractions. But as soon as you have this equal sign, you are comparing these two ratios and you have a proportion. All right, what I want you to do now is check this one and see if these two ratios are proportionate. The video is going to pause. Go ahead and find out. The answer to this one is no. These are not proportionate. Because when you simplify 6 over 10, if I divide by 2 to both sides, or to the top and the bottom, I actually get a 3 over 5. And a 3 over 5 is not the same as a 2 over 5. So these ratios are not proportionate. Now, not all ratios, not all fractions are going to simplify this nicely. All right, and as we get into more complicated problems, we need to know this property right here, and the means and extremes of the different ratios. So if you were to write your ratios out like this, with a semicolon, the means are these two numbers. So the ones closest to the equal sign. Okay? And then you have your extremes. Your extremes are on the far end, the furthest away from the equal sign. The reason why we need to know this vocab, means and extremes, is due to this means and extremes property. Okay? Now, pause the video if you need to write all this down, but all of this paragraph is leading up to cross multiplying. Majority of the time, when you are solving proportions, the fractions are not going to divide nicely. They're not going to simplify nicely. So this first problem that we did all the way up here, both of these simplified nicely, and you either knew that yes, they are proportionate, or no, they are not. But that's not always going to happen. Plus, it leaves room for math errors, you forget, and there's sometimes just ratios that don't work like that. So whenever you truly want to know the fail-safe way to know if two ratios are proportionate, you need to cross multiply. Now what this sentence is saying, what this sentence right here is saying is that cross multiplying only works if B and D are not 0. You cannot have 0 in your denominator, which makes sense. And then this right here is an example. So if I have 2 over 4, and I want to know if it's the same thing as 1 over 2, what I'm going to do is I'm going to cross multiply, and I'm going to multiply the denominator of one with the numerator of the other, and then same goes for the other side. And I can rewrite this as 4 times 1 is equal to 2 times 2. And we all know that 4 does, in fact, equal 4. But let's go ahead and do some slightly more complicated problems. Now, these first two, A and B, the top ones. In these two, you have decimals. Now, decimals are clearly harder to simplify, so you would definitely need to use cross multiplication to figure out, are these two things proportionate, are they similar? The way you would do that is you would set it up with the two ratios and the equal sign in the middle. In order to cross multiply, you need that equal sign. You have to have it. So from here, what you would do, again, the denominator of one to the numerator of the other, and the numerator of 1 to the denominator of the other, like that. And now I have 2 times 14 is equal to 3.5 times 8. I'll use parentheses so you can see decimals versus whole numbers. And when you multiply these, you get 28 equals 28. So yes, these two ratios are in fact proportionate. Now, B you're going to do on your own, but I want to talk about A, this next one, and this one. So the second A and the second B. In these ratios, you have variables. So you have one x over here and then an x minus 2 over here. The thing to remember is that even though these two proportions have variables in them, or in this case, a full expression, they still follow the cross multiplying rules. So even when you don't have all numbers, you can still solve. It's just your next step is then going to be solving for the variable. Now I'm going to let you do this first one. Actually, I want to let you do this one on your own. I'm going to show you 1B. That way you can see the more complicated problem. Now we have our equal sign. It's all set up. We can just go ahead and jump straight into it. So now I have, whoops, that's not a highlighter. then multiply the denominator of one to the numerator of the other, and then the numerator of one, all of this stuff, to the denominator of the other. And when I rewrite it, I will have 14 times 2, and I'll use parentheses again, is equal to 7 times the whole numerator, x minus 2. Because it's 7 times the whole thing. Then from here, you distribute and you multiply. So 28 is equal to 7x minus 14. Add 14 to both sides. And you have 42 is equal to 7x. The x value that makes this proportion work, would be 6. So whenever you have a variable, what you're going to do is you're going to set it up in parentheses and then distribute. Even on this first one, where you only have a single x, still set it up in parentheses. That way you get the chance to practice, and when you get to the expressions, it's a little easier. All right, the video is going to pause. Solve those two. And here are your answers. So in this first B, you can see an example of when the proportion, again, does not work out. And then 1A shows you all the different little steps for solving with a variable. Now, especially 1A and 1B, you are definitely going to need to know this for the rest of your math career. Okay, in geometry, we're about to get into a section where it's all ratios and proportions. So ratios and proportions are one of those things that does not go away. And the main place you're going to find them is in word problems. Okay, now in word problems, it's called rate, unit rate, and more importantly, scale or scale factor. And scale factor you'll hear a lot. Now these three words are just how ratios and proportions get described in the real world. So rate. Rate is when you are comparing two things that have different units. So $99 per 10 songs. Unit rate is when you want to know how many of one item is being compared to the other one. So the most common example of unit rate would be miles per hour. So if someone goes 70 miles in 1 hour, you are comparing how many miles they went in 1 hour. Not 3 hours, not 2 hours, but 1 hour. Okay? Or the flip side, how many hours, so I'm not sure for sure, but if you had 1 mile, the question would be, how many hours would that have taken you to go 1 mile? Okay? And scale is an example I used earlier when you have a model plane to an actual one, or if you're comparing the GPS map to the actual road. On the actual road, it may be a distance of 5 feet, 10 miles, whatever, but on the map, it's only an inch or a half an inch. In fact, in case you're interested, these three things, so ratios, proportions, these are the reasons why math was often considered to be the skill of the rich and the wealthy, because if you could make the maps, if you could do the proportions, all right, then it was a sign that you were very, very educated, which means you had money to do it. All right, but on to and back into math class. So if you're curious about old history and math, let me know. I've got some stories. But back to Common World math class problems. We have two examples of problems you'll see a lot. I'll solve the first one with you. The second one, you're on your own. We'll discuss it in class if you have any questions. Okay. So in the past 2 years, a retailer has opened 232 stores. If the rate of growth, remains consistent, how many stores will the retailer open in the next 3 years? Okay. This rate of growth remaining consistent just means that your two fractions are going to be proportionate. Okay, they're going to be equal. One's not going to be bigger, the other's not going to be smaller. In order for them to be a constant rate of growth, okay, they have to be the same. Actually, you can ignore my scribbles. the main thing you want, the main keyword is constant. So when you're doing this, it's important to set up your ratios in the exact same manner. So as I'm reading this, I see years to stores. So that's how I'm going to set up my fraction. I'm going to come over here and I'm going to write my model ratio of years to stores. When you're doing word problems, it's always a good idea to have this kind of model ratio. That way you don't confuse yourself and end up flipping the second ratio. So my first one is going to be 2 years and 232 stores. So 2 years, 232 stores. My second ratio, I have 3 years, but I don't know how many stores. So when I do my second ratio, I have 3 years on top, but I don't know how many stores, so that's my x. Now that we've got our proportions set up, we're going to cross multiply and see what this will take. Before you cross multiply, always check to see if you can simplify your fractions. And in this case, you can. 2 over 232 simplifies to 1 over 116. All simplifying does is spare you additional division and bigger numbers later on. And you guys know me, I don't like big numbers. Now you cross multiply. 3 times 116 is equal to x. X is equal to 348. That's how many stores they will set up within 3 years. So as a recap, when you're doing word problems, always have your model ratio. This helps you keep things consistent. Once you've set up your ratio, you're going to cross multiply and then solve for your variable. Although always double check and make sure that you are answering the question they're asking, because sometimes they'll ask you to give the ratio or they'll ask you for something else. So be sure you're reading your word problems carefully. Okay. You guys go ahead and do this one. The video will pause. You'll see the answer, and then if you have questions, we'll go over in class. Although I'll say this right now, do not be scared off by fractions. You're going to turn that into a mixed number or into an improper fraction first, and then go forward. Alright guys, good luck with the problem, and I'll see you in class. Here's your answer. As always, check for small math errors in both your work and mine, and I'll see you in class.